Hello, ladies and gentlemen. My name is Simon Timpson from the International Food Safety and Quality Network. Welcome to edition 82 of the Food Safety Fridays webinar program. Today, we're going to be talking about compressed air testing with Ruby Ochoa, who's the owner of Trace Analytics LLC. Trace Analytics are one of the sponsors of Food Safety Fridays, kind sponsors, along with AIB International, Metal Toledo, and Safe Food 360. These kind of organizations bring this free education to you most weeks, and you get a free certificate of attendance as well. So can't say fairer than that. Obviously, just to let you know, for the new ones in the sidebar, feel free to type your questions and comments and say hello to each other, as I know many of you regulars do. That's about it, I think, for now. At this point, I'd like to introduce you to Ruby. If you can switch your webcam on. Good morning, Ruby. How are you doing?
Good morning. I'm doing great. Thank you.
You're looking radiant as ever.
Too kind.
And can you let the ladies and gents know where you're calling from today? Where you?
Absolutely. Trace Analytics is located in the Hill Country, right outside of Austin, Texas. It's usually pretty hot here, but today it's raining, and we were spared any major hits from the hurricanes that happened not too long ago. But I'm very happy to be here, excited to talk to your group of folks.
Great. Well, it's great to have you. If you want to get your slides ready, I will talk about the next one. Right, ladies and gents. If you look in the tab, you will see George Howard, 360, measurement, they register for that.
Oh, no.
My voice is coming out quite loud actually on your side. I don't turn something down. But anyway, I'm going now. I'll leave it to you, Ruby. Okay?
What?
Yeah, I'll be back later. I'll leave it to you.
Good morning. Can you hear me, Simon?
Yes, can do.
Okay, let's get started then. I'm really pleased to be here. Trace Analytics is an A2LA accredited laboratory, and we're pleased to be able to bring this information to you. We're planning to talk to you about how to pass your next audit. We're going to go over the scheme requirements for those that have compressed air monitoring requirements, some guidance information, and then we're going to talk about how you apply HACCP principles specifically to compressed air. And I think that will be good, useful information for your next audit. We'll then talk about the air specs, the different ones that are available, and then a very brief description on how you would take a sample and the packages that we offer to meet your audit requirements. So these are the schemes that we're going to be talking about. And let's see what they have in common. BRC, and we didn't give you the full verbiage. We did cite where we found it, but we condensed it to the essence of what the requirement is. So BRC says air in direct contact should be monitored or shall be monitored. FDA says air should not pose a risk of contamination. IFS, air in direct contact shall be monitored. Compressed air shall not pose a risk of contamination. Primus says air in direct contact shall be monitored regularly. And then SQF has quite a bit more information in the various documents that they have. The requirement is, and you'll note that this is edition 8, which goes into effect in January. They've added a little bit, they've added some things to it. So air and gas in contact shall be monitored. They're talking about if you're using nitrogen or oxygen or carbon dioxide, those also need to be monitored. And then they also added the word systems. Systems must be maintained and monitored. And what they mean by systems, you've got a compressor, but you've got a compressed air system that includes the receivers, the piping, And all of that is what should be maintained and monitored. And of course, the filters. One of the things that is in an FAQ on SQF's website is that air at the point of use should be filtered with a 0.01 micron filter. We have, just so you'll know, at the very end of the presentation, we've got a couple of slides with links that will take you to a variety of information that we talk about during the presentation. And specifically, there's one there for SQF. They have quite a few different references to compressed air and recommendations that you will find useful. So this is just a slide that we keep showing. We keep looking for who out in the world is required to monitor the quality of compressed air, or who has regulations, who has specifications designated. This is just a little brief overview of those that we found that in some form or fashion have referenced ISO 8573. And I think Canada has their own requirements. So this brings us to our very first polling question. Does your country regulate compressed air quality in the food industry? Okay, so far we've got some from Canada and the USA, which were already on our map. In the next few slides, we're going to take the same HACCP principles you're familiar with and apply them directly to your compressed air system. With this information, you'll be able to document for your auditors that you are ensuring that compressed air is not going to contaminate your product. So let's start with principle 1. Identify hazards that must be controlled to acceptable levels. So what's the definition of hazard? A biological, chemical, or physical agent that is reasonably likely to cause illness or injury in the absence of its control. This is easy. You don't have to go digging very hard to find out what those are in compressed air. The experts like the Compressed Air and Gas Institute, the International ISO 8573, they all state that particles, water, oil, and microorganisms are the potential contaminants for low pressure air. Excuse me. Of course, untreated compressed air does contain contaminants, and they have to be removed or at least reduced to an acceptable level through filtration when used for food manufacturing, pharmaceutical, for critical applications. You certainly wouldn't use the same quality air that you would for, say, sandblasting or jackhammering rocks. That's a totally different application. Compressors used for critical applications are filtered to make the air safe for contact with your product. So let's move on to principle 2. Identify critical control points. A critical control point is a step where control can be applied and is essential to prevent or eliminate a food safety hazard or reduce it to an acceptable level. If an oil lubricated compressor is used, then that risk is addressed by using food grade oil, as well as oil filters. An oil-free compressor greatly reduces the risk of oil contamination, but there's still the possibility of introducing oil vapors into the compression process through the intake of the compressor. That's why it's real critical to always monitor what's going on where the intake of your compressor is. We found situations where your local delivery truck that brings you your packages every day are just letting their truck run, and your intake might be right there. Or your own operation might have vehicles or storing chemicals, you name it. If it can get into the ambient air, it will also get into your compressor, along with the normal things that are in ambient air like microorganisms and particles. So the use of adsorption filters remove oil vapors, and coalescing filters used to remove water and oil aerosols, also dirt, atmospheric dirt or particles, and of course microorganisms. Dryers further remove water vapor to a given pressure dew point. And of course, any point of use can be controlled by the use of a point of use filter to remove microorganisms from contacting the product. So these are your critical control points: your filtration, your point of use filters, your intake location. Those are all critical control points. Principle 3, establish critical limits for your critical control points. So that's where you're going to, either the engineers that determined what type of compressor system and filtration, they would have come up with those types of recommendations for the filtration, like you could use a refrigerant dryer or a desiccant dryer, depending on your product. Those type of systems are already in place. Then there's your point of use filters, where you can adjust the quality based on your product. And SQF recommends that at the point of use, you should use a 0.01 micron filter. And here's why. That point of use filter is your last defense before the air hits your product. And a 0.01 micron filter is going to remove bacteria, mold, yeast, your microorganisms. And these are the common ones that when we do a total plate count that we're checking for. So as you can see from the slide, the size of bacteria starts at 0.2 of a micron and goes up to 10 microns. Mold is bigger. It starts at 10 microns and can be up to 30. And yeast as low as 3 microns going up to 40. But once they hit your point of use filter, if you've got the proper filtration and the proper efficiency rating, SQF also recommends that it should be a 99.999% efficiency rating. So once these microorganisms hit your filter, you should be at 0 CFUs. And that makes it safe for your product. Principle 4, implement monitoring at a critical control point. So what is monitoring? To conduct a planned sequence of observations or measurements to assess whether the critical control point is under control, and to produce an accurate record for the future use in verification, which is a further step down in the HACCP plan. So, excuse me, I'm going to talk a little bit about 4 different monitoring plans, and the one that kind of matches up pretty well with your requirements. Let's start with the one that's marked 1, single. That means 1 sample, once a year, at 1 point. And I'll tell you what, 1 is a very lonely number. You don't get a lot of data from 1 sample once a year. The whole point of monitoring is to make sure that the compressed air is in a state of control all year long, not just once a year. So the plan that I like is the maintenance plan. That's where you're actually sampling right before you change your filters. That gives you worst case scenario. If you say you change your filters every 6 months, if you take a sample right before and you're in compliance and you're meeting the quality that you've established for your product, that's great. That means the last 6 months you were in compliance. If you're not, that can indicate to you that you're not changing your filters frequently enough. Something might be overcoming your filters too early. So it would certainly be reasonable and required for you to investigate why the quality wasn't good at that point. And then I also recommend that you take a sample immediately after you've changed the filters. That way you know where you're starting, at what point. Sometimes some of our customers have found that the filter isn't really quite working for their situation. I've got customers who have black iron piping throughout their facility. Their facility might be 30 or 40 years old, and they have a refrigerant dryer. So guess what that means? There's a lot of rust that's in that piping, and you can't avoid it. You have to filter it out. It's really important to not depend on the pressure differential gauge on those point of use filters. Because if you were to have a spike, and let's say you've got some large particles and they could break through on your filter, unless if you're standing right in front of that gauge and see when it spikes up, you won't know it an hour later, because it will have created a path for the air to very easily go through the filter. You'll never see a rise in that pressure on the gauge. So we recommend that you meet with your distributor that sells you your filters or your compressor. Determine by volume how much air you're passing through your filters. They know how much those filters can handle, and that will give you a better idea of how many months or hours on the compressor that filter will handle, and then you change them out. So I like the maintenance because it helps ensure that things are going properly all year round. The other two that I've included here is one is called a percentage type of monitoring plan. We've got some customers that have quite a few points of use. They might have numerous compressors and pipelines all over the building going into a different building, second story. And so they determine by a percent of how many samples they want to sample annually, or how many points of use they want to sample annually. They could say, I want to do 25% this year, or in the next 2 years or 3 years, I want to have every point of use measured. It's just a percentage. It's more random testing. You don't repeat on the same point of use. And it's just another monitoring plan. And in some cases, that is what customers want. The last one is called the minimal program. And in that case, what I would recommend is taking a sample as close to your main compressor system filtration to see what the quality is coming out of there, and then go to the furthest point of your line and take a sample there. Now, if you've got numerous compressors, going into a header and then they're splitting off, and it's not a shared receiver with the same blended air going to everywhere, then excuse me, you would want to take a few other points to make sure you cover all the conditions that might be there. Sometimes customers will have to add a new line, and so you should consider old piping versus new piping, and make sure that you're monitoring that as well. Principle 5, establish corrective actions when not in control. So these are the procedures followed when a failure occurs or a deviation occurs. Excuse me. Your HACCP plan establishes a strategy to prevent, eliminate, or reduce contamination. However, sometimes deviations occur. So what do? If you get air test results showing a failure for particles or microorganisms or, one of the contaminants, then you first have to determine if it has affected the safety of your product. That's why it's important to have individuals assigned to this task that have a thorough understanding of the process, your product, and the HACCP plan. Your written plan should identify if there are further steps in the manufacturing process that will lessen or eliminate the risk. In other words, if there's a kill step after the compressed air has touched your product, then that risk is very low then, right? Because you've killed any of the microorganisms that might be present. Then you need to identify the cause of the failure. It could be as simple as the filters weren't replaced when they should have been. You might find out that there's a malfunction of the compressor, or the maintenance is past due, or even perhaps a dirty nozzle or a piece of tubing that was connected after your point of use filter. If results show microorganisms, then you may determine that the environmental conditions in the facility or the sampling technique by the tech were the source of contamination. That's high risk for something like that to happen. And I'll address how we try to eliminate that the way we provide the sampling. We've had some customers who manufacture a product that creates a really fine dust on the manufacturing floor and in the air in the manufacturing production area. And it's impossible to get a clean sample because you can't get the cover off of the plate fast enough and into the sampler to not have that fine dust settle on the plate. I've also heard of a facility that wasn't a food manufacturer, but it's still applicable because there's excuse me, because of the, actually, I was going to talk to you about the pressure differential again, but I already mentioned it earlier. There was a kind of funny story about it. There was a new technician that was working on keeping the logs and making sure filters were changed properly. And she noticed that this one particular point of use had not been changed. A point of use filter had not been changed in like a couple of years. But every month somebody was going by and check marking that it was all good because they were reading the gauge. She got curious. She opened up the filter, and there was a hole inside that filter about the size of a nickel. And that filter could have stayed in there forever if she hadn't been curious. So that's why we don't like you to use those gauges to determine when to change your filters. So anyway, needless to say, you'll need to designate a person or a team to identify the problems, and then you might even have to call in outside experts to help you, since you might not have the in-house staff with sufficient experience to address, say, a problem with your compressor. Anyway, it will take a team to make sure that this is all working properly. And then, of course, the final step requires that you document all of your corrective actions because your auditor is going to want to see that. Principle 6, establish verification procedures. Those are activities other than monitoring that determine the validity of the HACCP plan and that the system is operating according to the plan. So verification is defined, as those activities. Well, what are those activities when it relates to compressed air? Well, first, you have to start with looking at your original HACCP plan. Make sure that it's still applicable today. Make sure that if you made any changes throughout the year, either to your compressor or piping, that they are now reflected in your HACCP plan. If you have a robust system, HACCP system, then you shouldn't require much in-product testing because the plan will have built-in safeguards. So that's why the verification step is so important. You should have a frequent reviews of your HACCP plan, verify that the plan is being correctly followed, review the results of your critical control point monitoring, and the corrective action records. You may need to perform further validations of your plan whenever there's an unexplained system failure, you add a new product or a process, or you identify new hazards. Here's an example of a HACCP verification schedule. Excuse me. There'll be a link to this at the end of the presentation. I found it on the FDA's website. It's a nice table for you to look at. You could very easily implement something like this, listing all the activities that you're going to do, and of course, include the frequency, who's responsible, and who's reviewing it. Establish record-keeping procedures. That's principle 7. That's the final one. We all know what record-keeping procedures are, right? But here's where you want to gather all the information regarding your compressed air system. You want to include your risk assessment, the limits you've selected for your critical control points, your air test results, any corrective actions, training records, sampling procedures, schedules, all of this in one place. So hopefully when the auditor is asking you questions, you've got it all in one folder. And you also might want to check out a previous webinar that we did in July of this year. We talked about how to perform a risk assessment, and it was an hour long, so obviously I can't go into that today, but it's there, it's recorded, and it's on this website. So just go look at the free Friday webinars, and you can type my name in, and it should pop up, or type in company name, Trace Analytics. There's also, if you do a search on IFSQN's website, you'll also find some articles that we've written. And the very, very first webinar that we did back in 2015 goes into pretty good detail about the contaminants and how they occur, the ones that come from the intake air, the ones that come from the compressor, and those that might be created in the piping or the receivers. So I was talking with a potential client not too long ago while I was preparing for this webinar, and he had just had his 4th audit. It was an unannounced audit, and I didn't know this, but you can only have the same auditor for 3 years. After 3 years, a new auditor has to come in. Well, he had been passing his audits just fine. He'd never been questioned about his compressed air. But then the 4th auditor came in and cited him for 2 compressed air related findings. If I guess you've had a chance to look at them, basically they were that there was no information documented on the air filter size and the maintenance of the hoses to ensure that they were maintained in good condition in a hygienic state. The other was that compressed air via the air hoses used to clean the product contact surfaces had not been tested for purity. Now, this particular company is, I believe, indirect contact. So here's what he responded to the audit findings. Obviously, he contacted us immediately. We were able to help him to get the testing done that he needed. Normally, I think he was given 2 weeks to fix everything. And that particular auditor did not budge about the timing. Usually they will give you a little bit more time because, bugs grow really slowly. When you do a micro test, it takes them a while to grow and they don't just happen overnight. But nevertheless, he was able to handle part of his minor findings. The first one was rejected. He had implemented, as you can see, a complete PM with filter changes being done, documentation of the filters, et cetera, et cetera. But the auditor came back saying, you didn't talk about your hoses. Provide me a maintenance program on monitoring air hoses to ensure that they are maintained in a good condition, properly repaired, and maintained in hygienic state. So yesterday he sent me what he wrote back to them, and I'm pretty sure that it's all going to be finalized, but he added additional information about how the hoses were going to need to be checked daily for visual, for whether they were stiff, as well as, the position of where they needed to be on the wall, things like that. So I just thought I'd provide this, thought you might find it of some use. We've got another poll. So we're interested in finding out what kinds of other microbial testing do you do at your facility. Hopefully you're doing compressed air testing. We want to know if you do environmental testing, product testing, water, steam. And if you could just type that into the chat, that would be great.
Ruby, can you hear me?
Now I can. Great.
Oh, yeah, I think maybe I was turned down before because the audience could still hear me. Anyway, so what kinds of microbial testing does your facility require? Air, water, steam, environment, or products? Just type in the sidebar and let's have a look what we've got.
All of them.
Okay, some are saying all of them. Air, water, environmental, product, water, steam, all except steam, water.
Well,
yeah,
lots of testing that's going on, looks like.
It does look like that, yeah.
Well, we appreciate you providing us a little bit of info on what you do there. Thank you so much.
Somebody just mentioned something, it's not your area, but somebody said, what about hand air dryers?
I'm sorry, say that again, Simon.
Yeah, somebody typed in about hand air dryers, the air dryers that you dry your hands with. About the air in those, obviously it's not compressed air. But I guess they're susceptible to probably microbes as well, perhaps, if they're not maintained and cleaned.
We've got a funny echo. I'm having a little hard time. Are you talking about HEPA filters being used to remove microorganisms in a facility?
No, it was somebody talking about hand dryers, for drying your hands after hand washing.
Oh, hand dryers.
Yeah.
Oh,
I guess what they were saying was, I suppose, after you've cleaned your hands, washed your hands, then you're drying them with air, then that air needs to be sort of hygienically clean and maybe no microbes in the dryer itself.
Huh. That's interesting. I'd never thought about that one.
Yeah. Anyway, that's a bit of the slide, so feel free to move on a bit.
Okay. So we're going to talk about compressed air standards and regulations. We frequently get questions about this. So let's review what's available. Are breathing air specifications okay to use for evaluating compressed air used for food and beverage manufacturing? That's a common question that we get. The short answer, No. Compressed breathing air is filtered differently than low pressure compressed air used for manufacturing. Compressed breathing air is typically with high pressure compressors for, say, firefighters, scuba diving. There's significant difference between the specifications. Breathing air filtration converts carbon monoxide into carbon dioxide. And of course, carbon monoxide, as we all know, is the silent killer. It's odorless and tasteless, but at high enough levels can cause death. Breathing air specs require dry water vapor for firefighter use so that it'll prevent the freeze up of their regulators. Whereas it either has no limit or has a much higher allowable level for sport divers or airline respirators users. Depending again on the usage, the levels of oxygen and gaseous hydrocarbons are limited, as well as condensed hydrocarbons or oil aerosols. Low pressure air is also filtered, of course, depending on its intended use. For the use of pneumatic tools or general use equipment, the limits are significantly less stringent. For air used for the production of products or highly critical applications, the filtration is designed to remove particles, water, and oil and microorganisms. So I'm going to show you a chart from ISO 8573 that addresses these contaminants, well, 3 of the 4 contaminants. Some of you may be familiar with this. Basically, here's the section for particles, water, and oil. And on the left-hand side are purity classes, starting with the most stringent of of 0, which is really something that is more unique than the average filtration that you would normally see. That would be something that would be agreed upon between the manufacturer and the end user that's specifying the requirements. But anyway, so class 1, class 2, we frequently hear of these. For particles, we're talking about particles by a size. So 0.1 to 0.5 microns in size. Second range is 0.5 to 1 microns, and then 1 to 5. What's also part of the requirement is that in order to meet class 1 through 5, you cannot have particles greater than 5 microns. Then you go into, then you go into a different measurement for particles, where we're not looking at particle size or quantity of particles, but simply weight by mass. And so these are generally ISO 8573. These are the ones that are commonly used for pneumatic tools. Then we've got the category of water. These class 1 through 3 would be for a desiccant dryer. And then the purity levels for class 4 through 6 would be for refrigerant dryers. You'll notice there is a liquid component to it, and this would be an extreme level here for particles, as well as for oil. At those points, we're not talking about monitoring. We're talking about trying to figure out where the contamination came from and how do we clean it and fix it up. So the purity classes that you're concerned with are those 1 to 5 in particles, any of the ones in water, 1 through 6, not the liquid. And then for oil, class 1 and 2 are a little different than the others, because ISO 8573 states that you should test it 2 different ways. One is to capture oil vapors, and one is to capture the oil aerosols. And then together, those 2 readings will be need to meet these limits. 0.01 milligrams per cubic meter for oil, and less than or equal to a 0.1 milligram for a class 2. When you get to class 3 and 5, then you don't need to do the oil vapor analysis because it would be insignificant when you've got readings at these levels. This is a chart that we put together, just categorizing the purity classes for you. If it is a high risk, critical application, then you could look at classes 1 to 2 for particles, 1 to 3 for water, that's a desiccant dryer, and 1 or a 2 for oil. If you've got medium to low risk, then this range of purity classes might be appropriate for you. And then down here remember I mentioned that class 6 for oil, that's for particles, that's typically for pneumatic tools. So this would be no contact. You wouldn't be worried about this unless if you have an instrument that does require some type of filtration and it falls into these ranges. These are just guidelines. Here are some specifics from the British Compressed Air Society. They've got an excellent guideline that talks all about compressors. It is a free download. I don't remember if we put it on our, yes, we did put it on our last 2 slides. So it'll have a link where you can go download that. But they recommend semi-annual testing of your compressed air, in that if it's direct contact, your purity class should be a class 2 for particles, 2 for water, and 1 for oil. If it's indirect contact, then it would be a 2 for 2. These readings, when you see them in brackets like this, usually you're going to have ISO 8573-1, and then the version of that document, which is currently 2010. And then in brackets, it will always be in the order of particles, water, and oil. If you use that type of description, you can very easily communicate to your laboratory, to your filter manufacturer, to your compressor manufacturer. We can all speak this language. It's a common language. Now, the second chart here, these are not recommendations. These are strictly examples of what some of our customers do. And in some cases, you'll see they're completely different. It's still a bread product, right? But this one chose a 242. This one chose a 222. I've got packaging companies that do a class 242. I've got a soft drink manufacturer that goes to the very, very extreme of 111. That's a tough spec to meet. Baby food, they performed their risk analysis and came up with these numbers based on the products. And in some cases, you may have numerous products that could have different purity. So that's where you could adjust your filtration at the points of use. Oh, okay. So now let's get to the requirements for microbiological testing. I wish I had more for you. They're just not out there. There are the requirements that even BCAS doesn't say it. ISO 8573 doesn't have a limit, although I heard that they are working on it. So maybe in the future we might have better guidance in that regard. But for now, what some of our clients do is they use their environmental limits that they have. Some of them try to apply their product limits. And in some cases, the limits of the findings from micro testing are so low that it is, they know that it's perfectly acceptable. So let's keep looking. If you find any, send them my way. We're always searching for this kind of information. So we're going to talk, oh goodness, we're running out of time. I'm going to need to hurry it up. We're going to talk a little bit about How would you take a sample? This is not full details. This is just giving you a glimpse. We collect particles with a pre-weighed filter. It's a membrane that collects particles, and then we take that membrane. Well, first, you have to run a known volume of air through it, and depending on the purity class, it can be a couple hours to do the sample, or maybe as little as 15 or 20 minutes to take the sample. So once we get the filter back into our laboratory, we take that membrane and look at it under a microscope, and we count how many particles we see by what size. That does limit us to only being able to look at particles 0.5 microns and higher. If you require the first range, as you remember on the purity classes of class 1 and 2, those ranges of 0.1 to 0.5, we can accomplish that for you as well. It's just we're going to need to use a laser particle counter to gather all that information for you. Water, we use a length of stain detector tube, and it's a simple 5 or 10 minute test. I think it's 5 or 12.5 minute test, depending on if it's a desiccant dryer or a refrigerant dryer. And it's when moisture contacts the chemical inside the tube, there's a reaction and there's a color change that will occur. And then we get that information from you and convert that information to pressure dew point. The oil is collected, like I mentioned before, in 2 different methods. The same type of filter or the same filter will collect oil aerosol, and the charcoal tube will collect the oil vapors. 2 different methods. The blue filter cassette, we're going to take the membrane out of that. We're going to weigh it because we know what the weight was before we sent it to you, and we know how much volume of air you crossed through that filter. We're going to be able to know exactly in milligrams per cubic meter what your results are for oil aerosol. Then as far as the charcoal tube, we will extract the charcoal tube when we get it, and then run it through our gas chromatograph mass spectrometer to give you oil vapors as well as organic solvents that might be present. Sometimes we find that there's other contaminants that don't put you into a non-compliant state, but that you might want to take a look and figure out where they're coming from. And yeah, I guess that's a very quick and brief overview. The oh, my slide's not moving. Let's see. There we go. Then the way we collect microorganisms is with the use of an Impassioned Sampler. This is going to give us quantitative results for you. We can report as low as less than 1 colony forming unit. We get 1 cubic meter of air to impact on the TSA agar plate. The piece of equipment is completely sterilized when you receive it. You have to take your samples in an aseptic manner, which means you wear gloves, you wear a gown over your clothes, keep your, put your hair in a cap. If you've got a beard, cover it up, because frequently what we find is that the people taking the samples can contaminate the samples. So that's why it needs to be done aseptically. One of the other things that we frequently find, I think I mentioned before, that in some environments at facilities, the ambient air is full of your product, fine dust, powders, and it makes it very difficult, if not impossible sometimes, to be able to get a clean sample from your compressed air. But this is a 10-minute test, and it's really not too difficult to do at all. So Let's see, how are we on time? Yep, we're going to run through these last very quickly. We know that one size doesn't fit everybody. So we've got a couple of different packages that we provide. If you have specific limits, say a class 221 that you need to meet, you would fall into our pro package. If you don't know but want to start monitoring, want to start gathering enough information so you can set corporate guidelines, then we would recommend a baseline test. And as you can see, the full range of ISO 8573 classes would be available for those two types of packages. This next package is for that mid to low risk that I talked about earlier. It's called a value package. It's not as expensive as the other packages. It takes less time to take the sample, and it will suffice. It will get your audit requirements accomplished. The micro sampler, like I mentioned, it's an Impassioned Sampler. It's 10 minutes long. We test for yeast, mold, and bacteria. Basically, it's a total plate count that we provide, and we can do gram staining and further identification. Okay, so compressed air monitoring is a requirement for several of the GFSI schemes. We talked about those. They're all pretty generic in their comments, but the essence is you need to monitor your compressed air. And hopefully the HACCP principles that we went through are going to be helpful for you when you're applying it to compressed air. And I briefly covered how to take samples. I'm sorry, we kind of ran out of time. I talked too long. But what I do want to say is that our sampling and our analytical methods are based on ISO 8573, which SQF recommends, and we trust is the right way to ensure the safety of your products. Now we're going to move on to the questions, Simon, and I thank everyone for spending this past hour with me, and I welcome you to contact me directly via email or phone if you'd like to discuss how you can start or improve your monitoring program.
Yeah, fantastic. And your contact details are on the PowerPoint that we will be distributing afterwards with the recording. Tori was doing a great job in the sidebar answering all the questions. So, yeah, although we have gone 55 minutes, lots of questions have already been answered, which is fantastic.
Wonderful.
Okay, so any further questions for Ruby while we have her here? Well, John, how do we test moisture to class 1?
Well, the best way to test moisture for class 1, that must mean it's super critical for it to be that dry, would be with a hygrometer, perhaps some type of installed monitor on your compressor that has sensors, electronic sensors. There's a variety of equipment. There's some that are handheld. Doing it with a detector tube, and if you're looking at a minus, even better than a minus 94, then the detector tube may not be the right way. We don't run into those very often, where they're looking for a class 1 for water, but there are methods available out there. It's going to cost a little bit to either install it permanently or to have the handheld monitor brought in.
Okay. John was asking, what plates do you use to plate for mold and bacteria?
I'm sorry, what?
What plates do you use for?
We use TSA plates, tryptic soy agar plates.
Okay. And I saw a question come past before. I think that the registrant was in Jamaica. Do you actually sell equipment as well, portable equipment?
Do we actually sell the equipment, did you say?
Yes.
Yes, we do. We sell the micro sampler. We sell our own equipment for the particles, water, and oil. And then the samples for micro, we can't accept samples from out of the country. just because the potential for them getting stopped at customs is too high. So, but for particles, water, and oil, we can provide the analytical services as well.
Okay, and
Any country.
right, and Lisa is asking, do you provide any on-site testing services?
You sounded like you were underwater. I'm sorry. Could you say that?
Do you provide any on-site testing services?
Well, we're the analytical laboratory, and as such, we don't have teams of technicians to send out, but we have great partnerships with distributors and consultants, and they are fully trained on our equipment and familiar with compressed air systems. So, and they're all over the United States. So, if you have a particular location in mind, give me a call. I'll see who I've got, and I'll send you the best one.
Okay, I'm sorry about this audio. I don't know what's going on. Angel is saying, we are a co-packer of dried ingredients with no temperature control or kill steps, and our products do not come into direct contact. Would you recommend we do baseline or just state that we fall under indirect?
Okay, so did he say that the air does come in contact with his product?
No.
There's no possibility of the compressed air touching his product through a conveyor, indirect or direct. Then it's not necessary to test if there is no potential for contact.
Okay.
If I understood the question correctly.
No. Tricia was asking, are there specific equipment and methods for testing other gas systems like nitrogen?
Yes, and especially for SQF, they're talking about not just the nitrogen, but the system that you've got in place, which would include piping. So there's some customers want to know the purity of nitrogen. There are various specifications. There is U.S. Pharmacopoeia spec for nitrogen. There's a European spec for nitrogen. And, pure gases are used everywhere. So there's the Compressed Gas Association has specifications for those pure gases. If you're generating the nitrogen on site, then more than likely you're going to want to check the quality of the air that's going into your nitrogen system. And then if there's a potential, if this is the piping that you're using, some of our customers also want to test the piping for particulates, let's say, or maybe just for oil. All of the contaminants that we can test for, we can also just do partially. You don't have to do all of them. So, yes, we can certainly do the pure gas testing.
Okay. And what micron size of filter do you recommend for compressed air sterilization?
That would be the 0.01 micron filter. Remember the slide that I presented? Now, I do want to make sure we're going to update the PDF, though, before you get it. There was a typo on the PDF. It's a 0.01 micron that will provide you with sterile, clean air. There's all sorts of filters. There's the kind that are stainless steel, and they can be sterilized when you replace the filters. And then there's others. So just make sure that you pick a filter that has a good manufacturer behind it. They know food and bev, so that they can communicate with you. They understand your problems. And then, of course, that it's sized properly for your requirements.
Okay, John, how much air needs to flow past your filter pad to get an accurate measurement?
So for the filter for particles, we need 12,000 liters of air to meet a class 1, which would be 0.01 milligrams per cubic meter. That's the limit that we're seeking. I believe our lower limit on that volume of air is 0.007 milligrams per cubic meter. And then depending on the purity class, if you need to go to a 2 or a 3, it's less. As I mentioned before, I guess a class 2 would be 1,200 liters of air. And I think class 3 and higher, it's 500 liters of air for particles.
And what about food packaging? So if compressed air comes into contact with food packaging that then comes into contact with food, do you need to test?
Yes.
Okay.
Simple answer. If compressed air comes into packaging and the packaging comes into contact with the product, that is contact. So yes.
Okay. And how do I test the integrity of the filters?
So there are different types of tests that can be performed on filters. If you're talking about a filter integrity test, there's certain ISO standards that would allow for that. There are different instruments that are available to do your own type of testing on the filters. We ourselves do not provide that service of a filter integrity test. And I hope I understand the question correctly.
Yeah. That was correct. Yeah. Yeah.
I think we were asked that question before. We can certainly provide you with more details of the equipment that you would need.
Okay, thanks, Ruben. And Jen's saying, what about bottle inverters and bottle blowers?
I'm sorry, Simon, could you say that again?
Bottle inverters and bottle blowers, is there a way to filter these?
Is there a way to filter them?
Yeah.
Well, so sometimes you're using equipment that, like these types of instruments he's talking about, or equipment that he's talking about, you're going to need to put your point of use filters as close as you can. It might not be at the very tip. It's just you need to recognize the importance of what you're adding after the point of use. If you're putting a rubber hose onto it afterwards, rubber sheds particles. If you, they get brittle, and there's all sorts of things that we found after point of use filters that are contaminating the product. The air is great up until that point of use filter, and then you put in a dirty nozzle onto it that's got growth in there or dirt, just filth, and that's not good. That's certainly not what you want on your product.
Okay, I think what we'll do, Ruby, we can collate all of these questions, and if we've missed any, we can follow up afterwards because we have run over. Thanks very much for the presentation and for bearing with the audio problems that we've been having. So much appreciated from myself and all of the audience here today. Thank you, Ruby.
Well, thank you. I appreciate everybody's time.
Yeah, I'll speak soon.
Have a good weekend.
And you too. Take care. Bye.
Bye.
All right, ladies.